Hello and welcome. This video is all about creating a complete EKS cluster using Terraform. On completion of Terraform execution, you will have following resources. You will have a VPC with 2 public and 2 private subnets, EKS cluster with managed node group and single node, VPC CNI Add-on with prefix delegation, and AWS Load Balancer controller. Once the cluster is ready, I will deploy a sample app and expose it via internet. So you can see how it will work along with the load balancer, and your application can be made available to the internet. Entire Terraform code is available in the Git repo, and the link will be provided in the description. Let's walk through some of the key parameters for this deployment. We'll start with the terraform.tf. In terraform.tf, I have 2 providers. One is AWS and another is Helm. For the AWS, I'm using a profile called Labs for authentication. And for the Helm, I'm using OIDC provider for the EKS cluster. So Helm provider is required because we are installing load balancer controller Helm chart using this Terraform. That is the reason we have a Helm provider. Okay, moving on to VPC. Here I'm using VPC module and specify name of the VPC, CIDR, and also creating 2 subnets, 2 in private subnet and 2 public subnet. And I'm also enabling NAT gateway. This is required because I'm provisioning all the managed nodes, EKS nodes, into private subnet, so they will need internet access. That is the reason I'm creating it. For the public subnet as well as private subnets, you need to have an annotation to enable the load balancer provisioning. So for the public subnet, we are using kubernetes.io/role/elb equal to 1. And for the private subnet, it will be internal ELB. So looking at the EKS cluster. So EKS configuration, again, I'm using a module and I provision the cluster name, cluster version. Cluster endpoint is accessible publicly. And I'm enabling IAM RSA for IAM permissions. VPC ID and subnet IDs are provided as input. I'm using private subnet because I'll be deploying my nodes into the private subnet. I'm creating a new node group and with a single node and spot instance to save money. Let's have a look at the EKS add-on. Here I'm installing the VPC CNI. I'm providing the version number and also a few options. Prefix delegation is a requirement if you are planning to use the ALB with the target type of IP. Warming ENI target as well as prefix are optional, but it's a good to have options. And the rest of the 3 options are mainly for the security group for pods. That is out of scope for this video. There are 2 parts to installing a load balancer controller. Number 1, creating IAM role and policies. Number 2, installing the load balancer controller using Helm chart. First of all, you will need an IAM policy that will allow load balancer controller service account to assume AWS IAM role. And in the conditions section, we are also mentioning which service account will be used by the load balancer controller. Here we are specifying the namespace and also the name of the service account. The next step is to create the IAM role and attach the STS policy and also provide a name for the IAM role itself. I always like to add the cluster name at the end of the IAM role so that it is easy to identify. And also, if there are multiple clusters in the same account and same region, it is easy to identify which cluster this IAM role belongs to. The next step is to create a IAM policy that will allow the load balancer to have enough permission for creating and managing the load balancers. And once that is created, we will attach them to the IAM role we have created. Moving on from there to install the load balancer controller Helm chart, we are using the Helm provider. We provide the URL, controller name, the chart version and chart name. And few variables are required. Cluster name, we must specify the name of the cluster. And this is optional default target type. I always like to use IP, so I'm already hard coding it. And you can always override when you create an ingress. We must create a service account and we have to provide a service account name. It's always a good idea to keep the service account name same as the IAM role, so it will be easy to map. On top of that, you also have to have an annotation. This annotation is the one which is mapping your service account to the IAM role you have created previously. So this is a critical step. If this annotation does not exist, your service account will not be able to assume the role created by that particular IAM role. Okay, we are now ready to execute. I'm already in the right folder and I'll do a Terraform init. Once it is done, I'll go for Terraform apply. And it's going to create all the necessary resources. It's going to take a while, and I'll pause the video now and I'll come back once it is complete, once the activity is completed. Okay, Terraform now completed. It created all the resources. Let's have a look at console, AWS console, and see what we can see. Your VPCs, you can see there's a single VPC created, 2 public subnet and 2 private subnets. So that's there. When you move on to the Kubernetes, you can see that there's a EKS demo cluster is created and it's running 1.29 version. And there's a API endpoint URL here. And also if you look at the add-ons, you will see Amazon VPC CNI is added. And also in the compute section, you will see a node group with a desired size of 1. Okay, so we are ready to go. We got a cluster running and we are ready to go. So first thing to do is to configure your command prompt, your CLI, update your kube config. Okay, so updated kubectl cluster info. We'll check the connectivity. Yes, we are able to connect. So I will use the K9s tool for exploring the cluster. So here you can see we got some of the ports and AWS node that is part of the VPC CNI and load balancer controller, and core DNS and kube proxy comes along with the EKS cluster. And if you look at the deployment, there is only deployment for the core DNS and load balancer controller. And if I look at the ingress, there's not a single ingress. Okay, now that the cluster is ready, let's move on to deploying a sample application. So we go into the sample app, with the README. I'm already in the sample app folder. I'm just going to apply the command, sample application. So if you look at it, you will see that being deployed. Okay, it's been created. It's creating 2 ports. We'll wait for it to be created. Okay, our ports are up and running. Okay, let's go and have a look at the ingress. Okay, here you can see the ingress created, that is echo.vetum.github.io, and it does have a load balancer. If you are not able to see a load balancer, most likely there is some issue with the permissions or something else wrong with the load balancer controller. So the best way to look at it is just to do a describe on the load balancer and look at the reason for it. Most common problem is to do with the annotation. Annotation is not matching the IAM role or the service account used for the deployment of the load balancer controller. So if you go into the console, you should see it's provisioning a new load balancer controller. So if you look at the load balancing, you can see it's provisioning a new load balancer, and it also created some rules. 2 rules are there, and for the main rule is sending to target group. It created a target group as well, and at the moment there is no healthy instances. Okay, I waited for a couple of minutes and let's refresh and see if it is ready. So refresh. Okay, we have 2 healthy targets, and also if you look at the target group targets, you will see it is going to the port's IP address and port's port. Let's go back to our terminal to check. So we have a load balancer being provisioned. Let's check if it is working, and we can resolve the load balancer URL. And let's look up for this one. Okay, the load balancer is ready and test. I do not have a DNS entry for this particular URL. So what we will do is we will use the curl command to pass host header and validate it. So here there is, okay, I'll set the ALB URL variable. And just do a curl to the URL, passing the host header. Okay, it works. Let's continuously ping and see if it is hitting both the ports. So I'm continuously doing it, and I can see it is the request being served by both the ports. So the load balancer is doing the work and it's sending the traffic to each port. Thank you very much, and hope you find this video useful.